Elon Musk plans to drag our civilization over to Mars and make us multi-planetary species. He has been developing an interplanetary vessel known as a Starship, launching fresh prototypes at an insane rate. He also said that he intends to fly a Japanese billionaire, Yusaku Maezawa, around the moon with the Starship in 2023. But how does the Starship work? And what's inside that giant shiny cylinder? Today we are going to take a sneak peek inside SpaceX's Starship, or should I call it a giant pointy cylinder? The British comedian's 2012 film The Dictator served as a Starship design inspiration, Elon Musk said on Joe Rogan's podcast. Sacha Baron Cohen can claim some credit for the sleek look of SpaceX's Starship rocket. The leader in the movie orders engineers to make rocket pointy to strike fear into his enemy. And actually, that's also what I said, Musk told Rogan. Rogan then asked if pointiness gives Starship an aerodynamic edge. It's arguably slightly worse, but everyone thought it would be funny if we made the rocket more pointy, so we did. That explains the rocket being pointy. But why do you think it's notably shiny? Because it's made of stainless steel. This is for a number of reasons, as Musk himself has helpfully explained. Musk said that it's obviously cheap, and it's obviously fast. And also it's fast in terms of production. Expense is another factor. Carbon fiber is more conventional rocket building material and costs something around $135 per kg, but 35% of the carbon fiber ordered for manufacturing needs to be scrapped. When wastages are taken into account after being cut to the precise size and shape needed to make a spaceship, the true cost of carbon fiber is actually around $200 per kg. Compare that to just $3 for stainless steel. However, there are no disadvantages to using stainless steel, because it has a high melting point and obviously is an advantage in rockets. Carbon fiber can only tolerate a steady state operating temperature around 300 degrees Fahrenheit, whereas steel can comfortably get up to and beyond 1500 degrees Fahrenheit without any stress. When we consider SpaceX's choice of fuel, cold liquid oxygen, and liquid methane, this shiny mirror-like thermo-reflective stainless steel offers the additional benefit of not turning brittle at ultra-low temperatures. The present alloy used, known as 301 stainless steel, certainly is seen in action for decades in space, but Musk looked into superior forms of stainless steel for use on his Starship prototypes. As he tweeted last year, we should be able to do better in the 2020s than they did in like the 50s. So I think we'll start switching away from 301 maybe in the next month or two. 301 stainless steel alloy comprises nickel, chromium, and iron and is more resistant to corrosion. 304 is similar with a higher chromium content, which makes it slightly less likely to corrode and slightly higher performing when it comes to bearing heavy loads at high temperatures. The rings you see running upside of Starship prototypes every 1.8 meters are in fact the result of using stainless steel instead of carbon fiber, 1.8 meters being the standard maximum roll height of commercial steel. More on what's inside the Starship. We can find a payload compartment at the top of the nose cone, which is of course left empty on current prototypes. But in time it will be fitted with a multi-functioning cargo bay once they get ease at landing the Starship. Crew quarters could hold about 100 people comfortably on a trip to Mars. However, that number could be increased. Elon said that you could conceivably have 5 to 6 people per cabin if you really wanted to crowd people in the Starship, but I think mostly we would expect to see 2 to 3 people per cabin, and so nominally about 100 people per flight to Mars. This payload bay would also host common areas, storage space, and shelter where you could hide from potential cancer-causing solar storms. While we are up here, it's worth pointing at Tesla's battery packs attached to car engines adapted from a design used in Tesla's Model 3. What are they doing up here? The concept design of Starship puts a premium on reusability, which means ultimately this giant steel beast has to land at some point. But unlike its cousin Falcon, which lands vertically almost as a matter of cost nowadays, the Starship is so huge it needs to do something different. The Starship upper stage takes a different approach. When it is ready to land, the ship initially re-enters the atmosphere at a 60-degree angle and then belly flops to the ground in the horizontal position. This mode of return relies entirely on the atmosphere to slow the vehicle's descent. The downside is that, in this configuration, Starship is inherently unstable. The vehicle, therefore, uses 4 steel landing flaps, positioned near the front and rear of the vehicle, to control its descent. This is much like a skydiver uses their arms and legs to control a freefall. It's quite different from anything else. We're doing a controlled fall, Elon Musk said during a Starship update. You're trying to create drag rather than lift. It's really the opposite of an aircraft. As Starship approaches the ground, It should be slow enough to execute an engine burn that flips the vehicle into a vertical position. It then uses the Raptors as retro rockets to guide the vehicle down to a safe landing. Musk says this general approach could be used to bring Starship down safely on any planetary surface in the solar system, Mars included. Tesla batteries in the top cone operate the activators that extend the flaps. Further down the rocket, we first find the liquid oxygen tank and liquid methane tank. This fuel mixture is conventional, compared to more traditional rocket fuels was chosen by SpaceX for several reasons. On balance, it's less dense and therefore less weighty than using hydrogen. It burns clean, which is crucial when you are hoping to reuse rocket engines again and again. Also thanks to the discovery of ice on Mars. After landing, a chemical process known as the Sabatier process will be used to gradually refuel the spaceship. This process uses a nickel catalyst to interact with hydrogen and carbon dioxide at elevated temperatures and pressures to produce water and methane, which is used as fuel. These two giant tanks contain a whopping 1,200 tons of fuel separated by a hemispherical bulkhead known as common dope. Back to the nose cone, where one of the head tanks is present and the others are sitting at the common dome. The nose cone head tank has a separate supply of liquid oxygen and the common dome head tank has liquid methane. These reserves are only bought online during the final stage of landing, once the main fuel supply in big tanks is exhausted. In this way, Starship's thirsty Raptor engines can enjoy fresh high-pressure methics when they most need it. This pressure is so crucial for their operation, Elon Musk specifically blamed inadequate fuel head tank pressure for the SN8 crash back in December. These smart head tanks also protect fuel reserves from burn-off, which is a significant problem on longer missions that are exposed to greater solar radiation. As Elon Musk said, history is going to bifurcate along two directions. One path is, we stay on Earth forever, and then there will be some eventual extinction event. The alternative is to become multi-planetary species, which I hope you agree is the right way to go. What do you think? Is this the right way, or Elon Musk is moving too fast?